So far, we discovered three different rules to help us understand how to expand some logarithmic expressions. So let's go ahead and do that. Let's look at some a little bit more complicated logarithmic expressions and see how we can expand them. So let's say that I have the log of b, log base b of x squared square root of y. Can you see how we might want to start expanding that? Well, the first thing that might be helpful is let's write everything within the parentheses with an exponent, because I see the square root right here. It might be easier to deal with it if it's in square root world. So root y in exponent world is y to the 1/2. Looks like I can use my product rule right here and expand that out so it becomes a log of x squared base b plus the log of y to the 1/2 base b. So I was able to use a product rule. Now I have powers involved. So I can pull those powers out. So this will drop down. So I can have 2 log of x base b plus 1/2 the log of y in base b. So there's the expansion of this initial logarithmic expression. The next one I want to write out. Double check that I wrote it correctly. I did not, so let's write it correctly. Light and day, just kind of wrote down the wrong problem. Again, how many times have you solved a problem correctly only to find out it was the wrong problem? All right, so how do we expand this out? Well, a couple things first. Let's write everything with an exponent that we can. So the cube root of x is x to the 1/3. Then looks like we have the quotient opportunity happening on. So let's go ahead and write it as a difference. What else do you notice here? Not done. 36 times y, and I can expand that out as well. Notice I'm subtracting the whole thing, so I better put parentheses around that to kind of keep track of what's happening. Whew, a lot of work there. All right, a couple things we can do. I'm going to deal with the subtraction sign first because I want to see each term. Is that a 10? No, that's a log. After a while, you lose track of what you're writing. Distribute the negative across both, so that becomes a negative log over here as well of y to the 4th base 6. I like common logs because we can just go with base 10s, but this is in base 6 world. So what do we do? What do we do now? Well, I have exponents in 2 places, so we can pull those out. So the first one becomes 1/3 times the log of x base 6 minus the log of 36 base 6 minus, I can pull that one out, minus 4 times the log of y base 6. One last thing that we can do, if you can see that. Do you think we can evaluate the log of 36 base 6? I think so. Did you get it yet? What's the exponent that turns a 6 into a 36? A 2. There is the expansion of this initial logarithm, and you're right, we just need to be careful as we're doing that because sometimes our handwriting turns logs into 10s and g's into y's and all those types of things. So the better that we can write, which I'm improving and working on myself, the better we can be able to flow through problems that just have logarithms in it.